Hello class, today we're going to start talking about logical reasoning. Now we'll start this with inductive reasoning. Now before we get into inductive and deductive reasoning, we need another little definition here, that is conjecture. A conjecture is an unproven statement that is based on observations. May be true, might not be true, we don't know. It's just, I saw this and so I think this might be true. Okay, so we're going to make a conjecture and test it about the product of three consecutive non-zero integers. Okay, so real quick, product, remember that means multiply. Consecutive, that's one number right after the other, so I'm like 1, 2, 3, 4, 5, 6, that kind of thing. And they can't be zero. Integers, not messing with decimals. So, how are we going to do this? How are we going to make a conjecture about the product of three consecutive non-zero integers? Well, you know what? Let's take a look at some. Let's test out, see what happens. So let's see. Let's try 1, 2, 3. 1 times 2 times 3 equals 6. Okay, that's great. Not really enough to make a conjecture on, though, is it? Okay, so let's get a couple more. Let's say 3, 4, 5. 3 times 4 times 5 is 60. And let's try something big. So 21, 22, and 23 is 10,626. Okay, so now let's make a conjecture. Well, let's see, all of these are all positive numbers. So let's say that's always going to be positive, right? The product of three consecutive non-zero integers, we're going to say it's always positive. Now, I want us to test this, okay? So we have to test it. That means we're going to try and prove it false. Is there any three numbers you can think of that you can multiply together, back-to-back, consecutive numbers, that will not give a positive answer? Well, notice it says integers. Integers could be negative, right? So these numbers that I plugged in, those are all positive. Let's try what happens if I plug in negative numbers. So negative 5, negative 6, negative 7 is negative 210. That didn't work. So our conjecture is false. Okay. What this is called a counterexample. This is an example that contradicts the statement. It shows that your original statement is a false statement. And so the important thing there, how many counterexamples did we find? We only found one. And that is all it takes. If you can find one counterexample, then your statement is a false statement. So something that is 99% true is 100% false. That's all it takes. One false example and the entire statement has to be thrown out. Okay. Now you could change that and fix it by saying, well, most of the time or some of the time. Then you're okay. But if you say it's always, then it has to be always. There can be no exceptions. We have an exception, so it's false. So let's try something else. Let's make another conjecture. Let's see here. We've got these answers here. 6, 60, 10,626, negative 210. You know what? Those are all even numbers, aren't they? So let's try that. Let's say it's always going to be even. Let's real quick see if we can find something, do something different, maybe get a different answer. Let's see here. So notice on all of these that I've tried, I started with an odd number, 1, 3, 21, negative 5. So let's try starting with an even number, see if that'll do it. All right, so 2 times 3 times 4 is 24. That's still even. So our statement is true, except it only takes one. Maybe there's one example somewhere out there that I haven't found. So maybe it's true. It looks true. We're not sure. Okay. Now, what we've done so far, this is inductive reasoning. It's based on patterns and past observation, right? We observed this pattern in our data that it was positive and we tested it. Now, okay, but we've observed that they're all even, right? This is something we have observed. It's based on patterns. This is inductive reasoning. Inductive reasoning moves from specific cases to a general rule. So we have this specific case. This time it's an even number. This time it's an even number. This specific case it's an even number. So general rule, it's always going to be an even number. Okay? Specific cases to a general rule. And it is used to form a conjecture. Okay? And that's what we did. We formed the conjecture. We made a good educated guess. Based on what we've seen here, we are going to make this conjecture. Okay? So, this is our conjecture that the product of three consecutive non-zero integers even. Do we know that this is true? Well, we can look at more. Okay, so I could come over here in Excel and let me It's cutting it off. Oh no. There we go. I could come over here in Excel, and I just made a list of a bunch of different numbers, and notice they all come out even. And so, hey, we've got a very good pattern here showing that it works. We've got a very long pattern, lots of data. We've got positives, we've got negatives. So is that good? Well, I don't know. It only takes one. But this is inductive reasoning. That's how it works. It can get you close, but it can't be used to prove beyond a shadow of doubt that this works. Okay? Inductive reasoning, a lot of times this is your intuition. I got a feeling that this is how it's going to be. Okay? Inductive reasoning. Don't know for certain, but I got a feeling. This is what it looks like. So here's some examples of inductive arguments. All the swans we've seen have been white, therefore all swans are white. That is an inductive. It goes from specific cases, the ones you've seen in the past, to say all swans are white. Is that true? No, there's black swans, there's brown swans. But yeah, that's an inductive argument. The cafeteria has served hamburgers every Friday this year, therefore they will serve hamburgers next Friday as well. Okay, well, you've seen it in the past. Does that guarantee there's going to be hamburgers on Friday? No, they might decide to serve pizza. You don't know. All known planets travel about the sun in elliptical orbits, therefore all planets travel around the sun in elliptical orbits. I don't know, there might be a planet somewhere out there that travels in an actual circle, and it's not an ellipse. We don't know. And since Chris is a good athlete, Chris's sister must also be a good athlete. These are inductive arguments. All right, so now what we're going to look at is deductive reasoning. Deductive reasoning is based on facts, definitions, based on rules. It moves from the general rule to the specific case. This works for everything, so it's going to work for this time too. Okay? And this is used to test a conjecture. It's not used to form the conjecture, it's used to test the conjecture. So we've got our conjecture here that the product of three consecutive non-zero integers will always be even. So let's use a rule. Okay, well, let's see here. If we're looking at three consecutive numbers and we're looking at odd and even, you've got two things that could happen. You could either have an odd number, an even number, and an odd number, like 1, 2, 3. Or you could start with an even number and it would be even, odd, even. 2, 3, 4. Right? Okay, so what does that mean? If we're looking at even, well, all even numbers are divisible by 2. Right? 2, 4, 6, 8. All divisible by 2. So we could write it as 2 times something. 2 times 1, 2 times 3, 2 times 4. 2 times something. So that means this odd, even, odd, and this even, odd, even could be rewritten as something, and then 2 times something else, or 2 times something, some odd number, and then another even number, right? Notice all of these are 2 times something, right? And if they're all going to be written as 2 times something, then, as we said up here, that means it's an even number, because it's 2 times something. And therefore, we have used deductive reasoning to prove that our statement is going to always be true. Not true with a question mark. We know for a fact this is going to be true every single time because we have these rules here that say it works every time, so no matter which case you use, it's going to be true. Here's some examples of deductive arguments. All dogs are mammals. All mammals have kidneys. Therefore, all dogs have kidneys. Okay, this is true, therefore this is true. So, since all squares are rectangles, and all rectangles have 4 sides, then any specific square will have 4 sides. All men are mortal. Mr. Barnett's a man, therefore Mr. Barnett is mortal. Penguins are birds. All birds have feathers, therefore penguins also have feathers, because they are birds. This is the rule, this is the way the world works. That is the definition of a bird, is that it has feathers. All right? So, just to review, deductive reasoning is based on facts, definitions, and rules. It goes from a general rule to a specific case, and we use this to test a conjecture. All right? Inductive reasoning is based on patterns and observation. Okay? It goes from this thing I saw here, this thing I saw here, this thing I saw here, to a general rule that's always going to be true. And we can use this to form conjectures. And remember, it only takes one counterexample to prove something is false. Okay? only takes one. Something that's 99% true is 100% false. All right? All right. And that is inductive and deductive reasoning. I hope you found that useful, and I will see you in the next video.